And welcome to this online revision session for AQA FP4, in which we'll be doing the June 2011 question 6 on matrices and transformations. As you can see, there are two parts to this question. The first part is related to three-dimensional space and transformations of a line, and the second part of the question is to do with two-dimensional space and transformation of a line. Well, going into the first part of this question, you can see we have the Cartesian equation of a line in the form x minus 1 over 2 equals y minus 2 over 3 equals z minus 3 over 6, and we have to find the vector equation. Now, if you remember, the vector equation of a line is written in the form r equals a plus lambda lots of d, where a is a known point on the line and d is the direction vector of the line. And in the Cartesian equation, the point on the line is given by the values subtracted from the x, y and z coordinates specifically, and the direction vector is given by the denominator of each of the parts. And so what you will write down is that the point on the line that you know is 1, 2, 3, and the direction vector is given by 2, 3, 6. Now, in the second part of the question, you're now asked to transform that line by this matrix. So if we write down the matrix, 4, minus 1, 1, and negative 3, 0, negative 1, we then got to transform the points of the line. So if we add the two parts together, we'll get 1 plus 2 lambda for the x coordinate, 2 plus 3 lambda for the y coordinate, and 3 plus 6 lambda z coordinate. And so now we need to do a bit of matrix multiplication. So it's row times column. So we've got 1, 4, negative 3 times each of these parts in turn. So we get 1 times 1, 4 times 2, negative 3 times 3, which adds up to 0. And then you get 1 times 2 lambda, 4 times 3 lambda, which is 2 plus 12, which is 14. Negative 3 times the 6 is negative 18. So add those together, we get negative 4 lambda. Similarly, we got 2 times 1, negative 1 times 2, and 0 times 3, which is 0. And then 2 times 2, negative 1 times the 3, and 0 times the 6, which will just give us an answer of lambda. And then we get 1 times 1, 1 times 2, negative 1 times 3, which again is 0, and then 1 times 2 lambda, 1 times 3 lambda, so that's 5 lambda, negative 1 times 6, that's negative 6, and that gives you a total of negative lambda. So that is the equation of your new line, the image. But you need to deduce that it's a line through the origin. So key thing is you've got to show that the point 0, 0, 0 is on the line. Well, you can see that if you put lambda equals 0, then r will equal 0, 0, 0, implying that the line is through the origin. Now, where do you get your marks from? Well, in part 1, you get the correct statement, both parts, and the form of the line as they should be, and you'll get 2 marks. If either the vector or one of the vectors is incorrect, or the form in which you've written the correct vectors is not right, you'll then only get 1 mark for that. On to part 2. We're using the correct method, showing that it's a suitable matrix multiplication times the vector of the line. You'll get a mark. And then if you get one of these entries correct, you'll get 1 mark. And if you get them all correct, you'll get an additional mark. And then finally, for explaining clearly that it's a line through the origin, you'll get the 4th mark. Right, on to part B. And you can see here we have the line L1 and L2 is the image under the transformation V with this matrix that we're given here. And in the first part we've got to find the image line L2 in its Cartesian form. So what we have to do is to transform the original line L1 by this matrix. Well, that line, again, we need to write it as an x and a y coordinate. So if x is little x, then y will equal a half x plus k. So we now need to multiply those together, which is going to give us 1 times x and the 4 times the 2x gives a total of 3x. And then we got the 4 times the plus k as well, so it's plus 4k. And then similarly we got 2 times the x minus 1 times the half x, which gives us 3 over 2x. And then we get a minus k in there. So that's our image of the original line, and we want that in its Cartesian form. So if we call the image line big X, big Y, then what we can do is to solve or eliminate the little x's from the 2 equations. Big Y equals 3 over 2x minus k, and big X equals 3x plus 4k. So if we double this second equation and take it away from the first, we'll have 3x, and then twice the 3 over 2x will give you a 3x, so when they're subtracted they disappear. So we got 4k minus 2k, which will give us 6k, equals big X minus 2y. And we wanted that equation in the form y equals. So if we rearrange that and divide by 2, we're going to end up with big Y equals a half of big X minus 3k, which is in the form that we require. Okay. That's our answer there. Now in part 2 we got to deduce that L2 is parallel to L1. Well, remember what L1 is. This is L2 here. L1 is the line y equals a half x plus k. And so we can see there that they both have the same gradient. So in part 2 of this question, you could start off by saying that L1 and L2 have a gradient equal to a half, which implies that they're parallel. Okay. And then it says find in terms of k the distance between these 2 lines. So you can see here I've drawn 2 parallel lines in preparation. We could say that one of these lines passes through k on the y-axis and the other one passes through negative 3k. Where they are, it doesn't really matter. But the key thing is then, if that's the case, that the distance from here to here along that line along the y-axis is 4 lots of k. Now the other thing we know is that this gradient is a half. And what we require is this perpendicular distance between these two lines. Now, if we look at the gradient of a half, we know if that's 1, that's 2, this angle in here is theta, so tan of theta equals a half, and that distance would be root 5. Now, if that angle there is theta, then in our triangle that we have, this angle in here must also be theta. So the distance that we require between these two lines, d, will be equal to 4k multiplied by the cosine of theta, which will be equal to, well, from this triangle, adjacent is 2, hypotenuse is root 5, so this is going to be multiplied by 2 root 5, which gives us an answer of 8k over root 5. Well, where do we get our marks in this question? Well, we're making this statement here, that we're multiplying this matrix by this coordinate on the line, we'll get 1 mark. But then obtaining by the appropriate method, then we get a method mark for that and an accuracy mark for getting the correct answer to the multiplication, and then showing that that then reduces to this equation of a straight line, y equals half x minus 3k. You'll get one answer for getting that correct from there. Part 2, for stating that the gradient of both lines are equal to a half, and that implies they must be parallel. You'll get an explanation mark for that. And then for showing an appropriate method in order to find the value of this distance, you get 1 mark, and then again an accuracy mark for getting the correct statement there. Well, I hope you found that answer useful. For additional support in your maths revision, please go to the Further Maths Support Programme website.